All right, this is going to be page 3 of your practice test. Now, remember that especially in a standard class, you'll be able to utilize your graph to help you get these intersections and make sure that you show work on your paper, regardless of if you did use your graph or not, to get full credit. So if I'm solving this, this might be a little bit different than you learned in your workbook, but I'm gonna solve it the way I normally teach it. And in that case, I'm gonna isolate the absolute value. So I'm gonna subtract the 5 from both sides. That's going to cancel those out, and that's going to give me -2 absolute value 3x plus 4 is equal to -8. The next thing I do is I divide by this coefficient. So this is going to be dividing by -2 because we don't want that number out in front of the absolute value. Those will cancel those out, and you will have the absolute value 3x plus 4 is equal to -8 divided by -2, which is 4. It is at that point where I write two different equations. I write 3x plus 4 equals +4, and I write 3x plus 4 equals -4. Now, if you did it with the negative distributing into the parentheses, that's fine too. This is just how I'm used to doing it prior to the workbooks. In both cases, I'm going to subtract the 4 from both sides. Here, it'll give you 0 on the right side, so it's going to be 3x equals 0. Here, it's going to give you -8, so that's going to be 3x equals -8. In both cases, I want to divide by 3. 0 divided by 3 is 0. This will be -8/3. It's fine to leave that as a fraction. There's going to be two solutions, x equals 0 and x equals -8/3, which is approximately, if you put that into a calculator, -2.66 repeating, so I can just round that to 7 there. So you'll see your answer could be represented as a fraction. Best to represent it as a fraction, but it could also be represented as a decimal there. So I'll circle all that. And it does say plug it in to show your work. No, you don't have to do that for every one, but at least use your graph to verify that it works. So how do we put this in our graph? In order to graph this correctly, it's best to kind of split your equation up into two sides. This is going to be one line in your Desmos, and the other one is going to be the other line. Now, if it's just the number by itself, make sure you do y equals. So you're going to graph both of those, then you're going to see where they intersect. And this does have 2 points of intersection. One at about -2.667, comma, -3, and one at 0. Remember, your answers are your x values. So -2.667 and 0 should match up with the numbers that we got here and there. So that verifies that your answer is correct. All right, number 12. Same deal as before. I'm going to subtract the number here. And that's going to give me 5 absolute value 3x minus 4 is equal to -5. Next thing I want to do is I want to divide that number out on the left side. So -5 divided by 5 is going to give me -1. And absolute values are not going to produce negative numbers. So this is going to be a no solution. So your answer should say no solution. There is no answer that's going to give you an output that'll give you a negative number. We're going to graph that to verify it. Go ahead and try it on your own. All right, I've graphed the left side of your absolute value equation, and I've graphed the right side, and I made sure I put y equals on the right side since it's just a number. Let's take a look at Desmos. I'm going to need to zoom out, so let's do that. And what we'll see here is that there's no point of intersection at all. This will keep going up from this bottom vertex there, and this will be a flat line at 3. So there's not going to be any points of intersection, therefore they don't cross, and no solution is appropriate. So visually, it'll look like, that, and that's going to kind of help you realize there's not going to be a solution. All right, try number 13. All right, number 13 is going to be a little bit trickier because of the x over here. So what we're going to do is we're going to we're first going to make sure we can get the answer with our graph, actually. So I'll kind of do it backwards, and then I'll show you by hand what you can do. So if you look at the graph here, I have left side and right side graphed. Looks like there's several points popping up, but the point that we're most interested in is right there. And it looks like it has that lone point of intersection, because you notice this black line has a steeper slope than the absolute value line on the right side. So the x value at negative 0.2 is going to be your answer. Now that's not unacceptable in the honors class to just write your answer and not show work. So we're going to put work on the paper. So here's how we're going to do it. We're going to write two equations. We're going to write it once with the negative on the outside and once with the positive. Now you could make the right side negative. It doesn't matter as long as there's a negative showcased in the two different answers. Now you're going to get two answers when you do this. Only one's going to work. So watch carefully. This is going to be negative 2x plus 4 equals 3x plus 5. I'm going to do just one at a time. Here, I'm going to add the 2x to both sides. And that's going to give me 4 equals 5x plus 5. Then I'm going to subtract 5 from both sides. That's going to give me negative 1 equals 5x. I'm going to divide by 5. And x is going to equal negative 1/5. Now that seems to be the same number as negative 0.2, and that does equal negative 0.2 if you calculated that out. That is going to be one of your answers. Well, why doesn't the other one work? I'll show you. So you're going to, in this case here, subtract 2x from both sides. And that's going to give you negative 4 equals x plus 5. Now you're going to take away the 5. And you're going to have negative 9 equals x. Now, if you go back into the original equation, absolute value of 2 times negative 9 minus 4 equals 3 times negative 9 plus 5. What's going to happen is, if I plug in negative 9 here, that's going to be negative 18 minus 4 is negative 22. The absolute value of negative 22 is 22. Now, if I plug in negative 9 here, I'm going to get negative 27 plus 5, which is negative 22. It doesn't work, okay? That gives me a solution that when I plug it in is no good. So we call that an extraneous solution. Use your graph to help you narrow down which one is going to work if you're having a hard time going back and plugging it in. But it's going to be this one right here and only this one. So just the one solution. All right, question 14. A shipping container is supposed to weigh 110 kilograms, but it can be off by as much as 3 kilograms. Write a model, absolute value inequality to model this problem. These will always look like the following. Absolute value of x minus some sort of target weight. It should be less than or equal to how much you can be off. We call that the error, or the tolerance, I should say. So in this case here, what's your target weight? Well, that's 110. That's going to go right there. Your error, and I just covered it up. I can't even read that. Hold on a second. All right, I had to pull up my recording. It says, or my document says 3 kilograms. So let's go ahead and make sure we fit that in there. So it's going to be 110 here, and then 3 there, and it'll always have a less than or equal to absolute value. They just always look like that. So absolute value x minus 110, less than or equal to 3. Now, as far as solving it goes, you're going to solve it basically like this. You'll say x minus 110 is less than or equal to 3. And then you could say x minus, or negative, parentheses, x minus 110 is less than or equal to 3. Or sometimes you could just, some people do x minus 10 is greater than or equal to negative 3, but either case you have two answers. At the end of the day, you're just adding and subtracting from 110. So this is going to be plus 110. And so x is going to be less than or equal to 113. Over here, if I distribute that negative, that's going to be negative x plus 110 is less than or equal to 3. So I want to subtract 110. And that's going to give me negative x is less than or equal to negative 107. Well, when we divide by negative, it reverses everything. So if I divide by negative x, or sorry, negative 1, that's going to be x is greater than or equal to positive 107. How we visualize that on a number line and solution-wise is going to look like this. You'll say smallest number, largest number, everything in between. So everything less than or equal to 113, but also greater than or equal to 107. Remember, your target, 110, should be right in the middle, 3 units away on either side. The actual solution will look like this. Okay. Let's look at number 16. You're going to solve an inequality here, and number 17 also has another inequality. All right, for 16, to solve this inequality, you're going to add the 12 to both sides. So that's going to give you 4, absolute value 3x minus 2 is less than 8. Next, we're going to divide by 4. And that's going to give you the absolute value 3x minus 2 is less than 2. And because this inequality is opening the same way as this, you can expect that's going to be shaded between. So before you actually go through solving it, it's okay to graph it and kind of look visually what that graph's going to look like. So I'm going to go ahead and I'm going to show that for you on Desmos. You can type it in like this. All right, so pay kind of attention to how I type that in. Look, you pause the video and try to type it in yourself so you can see. I'll always graph the left side of the original equation in one line, the right side in another, and make sure you do y equals if it's just a number. Then in inequalities, I actually put the whole thing in line 3 so I can see the shading part. So if you look over here, let me hide this part first. The graph is asking when is it less than negative 4. So anywhere between these two numbers, between these 2 points of intersection, the graph is below it. If you look at the shading, you'll see that it's dashed line because it's not equal to, and it's going to be between the points 0 and 1.333. So decimal wise, it would look like open circle, 0, 1.33, which we'll write as an actual fraction here, and everything in between. Now that 1.333 is actually going to be a fraction. And the only way you're really going to get that is solving. So graphically, it'll look like this. This is actually 1 1/3, which is actually, if you do the math, 3 times 1 plus 1 is 4/3. So let me show you how to solve that using your equation by hand. So I have this absolute value, 3x minus 2 is less than 2. And if the inequality symbol is kind of bothering you at that point, if you want to treat it like equations, you can just say 3x minus 2 equals 2, and 3x minus 2 equals negative 2. And don't worry too much about the shading since you know where it's supposed to be shading here anyway between those. So in this case here, I'm going to add the 2 to both sides. That's going to give me 4. So 3x equals 4. And if I divide the 3, 4 divided by 3 is going to be 1.33 repeating. So that's 4/3. And so that's where this number comes from. Over here, you can expect to get 0. If I add the 2, that's going to give me 0. If I do 3x equals 0, then I can divide by 3 and also get 0. So x will also equal 0. And again, my solution on the graph is going to look like this. Since it's shading between, you'll write 0 less than x less than 1.333 or 4/3. So your inequality answer should look like this. All right, last one on this page. Number 17, solve the following inequality for X. Show work. Graph your solutions on the number line. This one, I don't like this 5 hanging out here, so I'm going to multiply both sides by 5. And that's going to give me 20. So that'll cancel that out. So I have absolute value X plus 3 is greater than or equal to 20. All right, so we're going to have the same situation as before where we're going to have an inequality. And before you get into the shading part, just ask yourself about this, the way that it's opening. On the previous answers, you'll notice that they were being less than or equal to, so they were shaded between. Well, this one here is going to be greater. So we're looking apart from where those two graphs intersect. So I would try to visualize it on Desmos here. I'll pause it and put it on there. Here I have left side graph the original equation, y equals 4. Again, make sure you do y equals. And my goal is to figure out when the graph is greater than or equal to 4. Now I'm going to hide this one here. And I'm going to zoom out a little bit. And this graph intersects in two spots, negative 23 and positive 17. But you'll notice the graph is greater than this flat line when it's going apart from those two numbers. Now, if I show the shading, you're going to see that it's shading to the right of this value of X, which is 17, and to the left of negative 23. And that solid line means that it's going to include those numbers. So number line wise, it's going to look like this. Closed circles, negative 23, 17, shade there, and shade there. What that looks like as a solution is X is less than or equal to negative 23. And then you say, or X is greater than or equal to 17. Because they're going in opposite directions, you need the word or between those. Here's the work by hand, because you will need to show that on your hand test. So if I'm solving this after I multiplied by 5, I'm just going to set up my two equations. I'm not even going to worry about the inequality because I know the shading part. So I'm going to say X plus 3 equals 20. I'm going to say X plus 3 equals negative 20, two solutions. And in both cases, all I got to do is subtract 3. And in this case, I'll get 17. And that's this number here. And in this case, I'm going to get negative 23. And that's that number over there. So what I circled is the answer. Here's the number line. This page was probably the longest page in terms of the amount of work that you'll need to do, but make sure that you do all the work on it so that you're prepared for your test. Next video, we'll go over page 4.